Hey viewers, welcome to today's class. Today we are going to solve a problem on vectors. So let's begin. Given that A is equal to I plus j minus 2k, B is equal to I plus k, and C is equal to 2i minus j plus 3k, find the modulus of the vector 2a plus b plus 2c. Firstly, we need to have a basic understanding of the problem we are to solve. We need to know that there are three vectors in this problem. We have vectors A, B, and C. By the way, what is a vector? A vector is simply a physical quantity that has magnitude and also has a direction. On the flip side, a scalar is a physical quantity that has magnitude but has no direction. In simple terms, the difference between a vector and a scalar is the fact that a vector has direction while a scalar does not. Examples of vectors include displacement, velocity, and acceleration, just to mention a few, while distance and speed, on the other hand, are examples of scalars. Back to our question, we have three vectors A, B, and C, where A is a three-dimensional vector, B is a two-dimensional vector, and C is a three-dimensional vector. Also, we have to find the modulus of the vector 2a plus b plus 2c. 2a plus b plus 2c is a vector we don't know. So to find it out, we are going to first of all find the vector 2a, the vector b, and the vector 2c. And then we add the three vectors together to get a single vector. I hope it's clear. So just as in normal mathematics, where 2a is equal to 2 times a, the vector 2a is going to be equal to 2 multiplied by vector a. Vector a is equal to I plus j minus 2k, therefore vector 2a is going to be equal to 2i plus 2j minus 4k. I hope you understand. Okay, so let's move on. Vector b is already specified in the question, so we'll be going ahead to find vector 2c. Same procedure is going to be applied here since vector c is equal to 2i minus j plus 3k. Then vector 2c is going to be equal to 4i minus 2j plus 6k. Next step is to add the three vectors so they can become one. In case you did not know, vectors can be added together. Vectors 2a plus vector b plus vector 2c is going to be 2i plus 2j minus 4k plus I plus k plus 4i minus 2j plus 6k. What we are going to do next is what we know as collecting like terms. So by doing so, we would have 2i plus I plus 4i plus 2j minus 2j minus 4k plus k plus 6k. Well, I just rearranged it for simplicity's sake. Nothing much was done here. So vector 2a plus b plus 2c is now going to be equal to 7i plus 3k. We are almost done. The last step is to find the modulus of the vector. But before we do that, what is the modulus of a vector? The modulus of a vector is simply the length or distance of a particular vector. So how do we find the modulus of a vector A? Where A is a three-dimensional vector with unit vectors I, j, and k. To find the modulus of vector A, we have to individually find the square of the coefficient of the unit vectors I, j, and k. In this case, the coefficient of I is equal to 1, 1 squared is equal to 1 also. The coefficient of j is equal to 1, 1 squared is equal to 1. The coefficient of k is equal to 1, and 1 squared is equal to 1. So therefore, the modulus of vector A is going to be equal to the square root of 1 plus 1 plus 1, which is equal to the square root of 3. You would understand it better when we apply it to our problem. So we know that our vector 2a plus b plus 2c is equal to 7i plus 3k. The coefficient of I is equal to 7. 7 squared is equal to 49. The coefficient of k is equal to 3. 3 squared is equal to 9. Therefore, the modulus of the vector 2a plus b plus 2c is equal to the square root of 49 plus 9, which is equal to the square root of 58. And that is our final answer. I hope all what I did was clear and understandable. I also hope you learned a thing or two from this video. Please like the video, share your comments in the comment section, and subscribe to this channel because a whole lot of educative content is going to come your way. God bless you.